All right, guys, this is the second recording covering the example 2 on lecture 7 in reaction engineering. So let's go ahead and jump to OneNote and get started. Okay, so this is another reaction comparison, and the example asks what conditions in reactor type favor the formation of R. So in this case, what we're looking at is R being a reaction intermediate, where A goes to R, but R can also react further into another product, S. And so we're looking at a comparison of these two reactions. So looking at the reaction expressions, we see K1 naught times E to the negative 6,000 over RT times CA and R2, K2 naught E to the negative 6,000 over RT CR squared. Okay, so looking at this, I see R is an intermediate. So I got to figure out, in a real sense, how would we maximize overall production and yield of R over S? And so when you're looking at a reactor intermediate, the first thing you consider is, well, a plug flow reactor allows you to kind of identify what's the optimal volume and length to get good conversion of that intermediate without having that secondary reaction kind of overtake. And so for this, I would definitely recommend a plug flow reactor. Now, looking at the activation energies, they're unfortunately the same. So manipulation of temperature is not going to do a whole lot in terms of selectivity. I'll go ahead and write that down. So I can look at my concentrations here, Ca and Cr. So it looks like my first reaction is first order in A. So I would like to have a pretty nice concentration of A to favor that R formation. And I would like a low concentration of R in my reactor, which seems counterintuitive, but what that tells me is I want a low single pass conversion. So I'm going to most likely rely on recycle and good separations to get decent overall conversion within my process. Lastly, looking at this system, I can also say, well, since it's second order and first order in A, I can say that a low reactor pressure will favor R formation. So that about does it for this tutorial. If you guys have any further questions, as always, feel free to send me an email. But take care, good luck, and I hope you're all doing well.